We're going to take a look at a couple of examples to wrap this section up and try and bring together a lot of the same ideas that we've been discussing throughout this first section. So our first example says, suppose that roughly 7% of undergraduate students at a university are vegetarian. What is the probability that among a random sample of 3 undergraduates, at least 1 is vegetarian? So this is, I'll be honest, a pretty difficult problem. I'm going to start off by thinking about this phrase right here, at least 1. So we're talking about 3 undergraduates that we're selecting. If I think about if I write this out, we have basically 3 people that we're selecting. I want to consider the number of vegetarians that I could have in this particular random sample. So if I was to just think about the number of potential vegetarians that I could have, well, perhaps none of them are vegetarian. Maybe 0 of them are vegetarians. Maybe 1 of them is. Maybe 2 of them are. Or perhaps maybe 3 of them are. I can't have more than 3 in this sample because I only have 3 individuals. So my options are 0 vegetarians, 1 vegetarian, 2, or 3. So this is essentially the sample space for the number of vegetarians that I could have. I want to think about what this phrase at least 1 means. When I say at least 1, first of all, 1 is at least 1. When I say at least 1, what that means is 1 or more. So it could be 1 or more. So this is at least 1. It could be 1, it could be 2, or it could be 3. So I see 2 different ways that I can approach this problem. I can say, well, if I want to calculate the probability that at least 1 of these individuals is a vegetarian, I would have to find the probability that exactly 1 of them is a vegetarian, and then the probability that exactly 2 of them are vegetarians, and then the probability that exactly 3 of them are vegetarians, and then add those probabilities together. So I would be finding 3 separate probabilities and then adding them together. That sounds like a lot of work. The other way that I could approach this problem is I could say, hey, the only number that I didn't count right here is 0. This is the complement of what I am looking for. It would be a whole lot easier to use the complement, and then I know, hey, if I want to find the probability of an event, actually, let's write it down here. The probability of an event can be found by 1 minus the probability of its complement. So if I can find this probability, the probability that there are 0 vegetarians, then I'll have my answer. I can just find 1 probability and then just do a little bit of subtraction at the end of this. So the complement then is 1 minus the probability of 0 vegetarians. Now, this is going to be a little bit tricky. 0 vegetarians means none of them are vegetarians or vegans. We're going to focus on finding this probability. So 0 vegetarians, I've got 3 different people in my sample. 1, 2, 3. And I need all of them to not be vegetarians, which means this is an and probability. I'm going to be multiplying these all together. So actually, I'm going to have to do a little bit of scratch work here off to the side. I want this person to be not a vegetarian, and this person to be not a vegetarian, and this person to be not a vegetarian. Now, I don't have that probability. If I scroll back up and read this problem, it said 7% are vegetarian. So the probability that they are vegetarian is 7% or 0.07. So the probability that they are not vegetarian, well, look at this. I'm using the complement twice in this problem. The probability that they are not vegetarian would be 1 minus 0.07 to end up with 0.93. So the probability that the first student is not a vegetarian is 0.93 times the probability that the second student is not a vegetarian is also 0.93. And the probability that the third student is not a vegetarian is also 0.93. So I'm going to multiply these 3 numbers together first. Let me grab my calculator here. I want to take 0.93 times 0.93 times 0.93, and I ended up with here 1 minus 0.804 4 if I round to 4 decimal places. And then I can just subtract these because I know that's how the complement works. I don't actually want this probability, I want the complement of that probability. So 1 minus 0.8044 gives me 0.1956. There is my probability. So these problems, I will be the first to admit, are pretty difficult. I think that probability in general tends to be a pretty challenging section. So I recommend if you come across problems that you're finding difficult or you're getting stuck on, try to write out different things that you know. So in this case, I think writing out the number of vegetarians that we could potentially have in our sample was extremely helpful. And then we could say, okay, here's what at least one means. And then that led us to thinking about the complement instead.